This video will talk about constraints in supertype and subtype relationships, and we will cover two types of constraints: completeness constraints and disjoint constraints. So let's start with completeness constraint, which is a type of constraint that will address whether an instance of a supertype must also be a member of at least one subtype. So it is going to tell me if an instance can be an instance of a supertype alone, or it must be an instance of the subtype. We'll have two possible rules in this case: total specialization and partial specialization, and let's see what each one of those mean. So the total specialization rule means that each entity instance of the supertype must be a member of some subtype in the relationship. So whenever I have an instance inserted into my database, it has to belong to one of the subtypes, and it cannot just belong to the supertype alone. Let's see an example. If I have this business rule that says a patient must be either an outpatient or a resident patient. So what I'm saying right here is it cannot just be a patient. It has to be one of the subtypes. I need a way to represent this, which is going to be represented by a double line extending from the patient entity type to the circle that is going to be between the supertype and its subtypes. So it is going to be represented by something like this ERD. I have the patient entity type, and then I have the double line here denoting that it is a total specialization, which means I cannot just have a patient, but it has to be either an outpatient or a resident patient. Now what's going to happen when I insert any record in this? Let's look. So every time I insert a new instance of patient into the subtype or supertype part of my database, a corresponding instance is inserted in either outpatient or resident patient. And whenever I insert something into a resident patient, remember we have this relationship here, which is assigned a bed. So an instance of this relationship is also going to be created and assigned, and this patient is going to be assigned a bed. But when I insert something into outpatient, I will not have this relationship, because remember, every relationship at the subtype level is specific to that subtype only. If I have it at the supertype level, then it's going to be for all subtypes. So is cared for is going to be for both subtypes, but is assigned is going to be just for resident patient subtype. Now what about partial specialization rule? It says that an entity instance of the supertype is allowed to belong to any subtype, but it also can be just part of the supertype. So recall this example where we had the motorcycle, which is a type of vehicle, but it's not represented in this ERD because it does not have any specific attributes or specific relationships. So it's all covered by vehicle. Now, if by partial specialization we say, okay, a vehicle can be a car, or can be a truck, or can be something else, which might be a motorcycle that is covered under vehicle on top right here. So again, if a vehicle is a car, it must appear in an instance of car. If it's a truck, then it must appear as an instance of truck, as we saw in the ERD. However, if it's a motorcycle, it will not appear in any of those subtypes because it is going to be for the supertype alone. Now let's talk about disjoint constraints. So disjoint constraints will tell me whether an instance of a supertype may simultaneously be a member of two or more subtypes. So can I have an instance that is going to belong to more than one subtype? This is what can be told by disjoint constraints. We have again two possible rules for this: the disjoint rule and the overlap rule. So let's talk about each one of those in more details. The disjoint rule specifies that if an entity instance of the supertype is a member of one subtype, it cannot simultaneously be a member of any other subtype. So it says if I have an instance that belongs to one of these subtypes, it can only belong to that subtype and it cannot belong to another subtype at the same time. So we will denote this by the letter D, which is going to be placed in the circle that is going to be between the subtype and the supertype. And we can see it right here. When I have the disjoint here, it tells me a patient can either be an outpatient or a resident patient, but cannot be both types of patients at the same time. So the business rule is going to be the following. At any given time, a patient must be either an outpatient or a resident patient, but cannot be both. Where do we see that it cannot be both? By the letter D right here. So this means it cannot be both at the same time. And again, this is the disjoint rule, which is specified by the letter D in the circle right here. What about the overlap rule? So you might have guessed it, the overlap rule means an entity instance can simultaneously be a member of one or more or subtypes. So it is the opposite of the disjoint rule, and it's going to be denoted by the letter O in this circle again. So let's look at this example. So we have the entity type that is part that has two subtypes, manufactured part and purchased part. But let's look for an example that will make this true. So for example, consider that we have part number, let's say 4,000. And at a given time, the quantity on hand for this part might be, let's say 250 parts. 100 of those parts are manufactured in-house, but then 150 of those parts are purchased parts. So a part can belong to purchased part and can belong to manufactured part. And that is why we say, okay, we have the overlap here that tells me a part may belong to both of those subtypes. And this will work with this constraint, which is the disjoint constraint, will also work with the completeness constraint. In fact, we'll often use both of them to really tell the business rules of our ERD.